morning. We need to find the general solution of these two differential equations that are in P and Q, right? Because these are in P and Q, so we are interested here to use the Lagrange's method. So let's start with the solution. First equation is this, and let's write the subsidiary equations. So that is dx divided by the coefficient of p, z square minus 2yz minus y square equal to dy divided by the coefficient of q, that is xy plus xz equals to what is present on the right hand side. Dz divided by what is present on the right hand side, xy minus xz. If I multiply this denominator with x and this denominator with y and this denominator with z and add all these, I will be getting this to be equal to 0. So I am using the multipliers x, y and z. So using the multipliers, this is the one way of getting the solution. X, y, z. We get x dx plus y dy plus z dz to be equal to 0, right? So when integrating both the sides, we are getting integrating with respect to x square divided by 2 plus y square divided by 2 plus z square divided by 2 equal to the constants, let's say c. And this further implies we can take 2 to the other side. X square plus y square plus z square equal to 2c, and let me take this constant now to be c1, where c1 is 2c. c1 is constant. So this is the one way of getting the solution. The another way, let's consider these two ratios. Taking x common from this denominator and also x common from this denominator, we get, from here we get x into y plus z, and from here we get x into y minus z. X cancelled out. So on taking x common from the denominators from the last two ratios, the second way, the last two ratios gives, this is dy divided by y plus z equal to dz divided by y minus z. On cross multiplying we get y minus z into dy equal to y plus z into dz. Opening the brackets, y dy minus z dy equals to y dz plus z dz. Taking everything to the left hand side, we get y dy minus z dy minus y dz minus z dz equals to 0. And taking first and the last term together, that is y dy minus z dz, and rest of the terms together, minus z dy plus y dz equals to 0, right? Okay, how can I write this? I can write this as the derivative of y square divided by 2 minus z square divided by 2. Can I write like this? When you take the derivative, you are getting back these two terms. Minus, I can write this to be as the derivative of yz, isn't it? The product formula, right? Okay. So writing this further as y square divided by 2 minus z square divided by 2 minus yz equals to 0. Now integrating both the sides, we get y square by 2 minus z square by 2 minus yz equals to constants, let's say c2. which can also be further written as y square minus z square minus 2yz equal to the constant c2 dash. Multiplying 2 with c2 and taking that constant to be c2 dash. So this is another way of getting the solution. And now writing the final solution, that is f of c1, c2 to be equal to 0. What is c1? It is x square plus y square plus z square, right? X square plus y square plus z square, and c2 is this. Okay, c2 dash. So this is y square minus z square minus 2yz. This is the required solution. Let's move on to the next differential equation. P plus 3q equal to the right hand side. Okay, how to write this? Let's write the subsidiary equations. The subsidiary equations are dx divided by the coefficient of p is 1, dy divided by the coefficient of q is 3 equals to dz divided by what is present on the right hand side. Yes, considering these two ratios first, from here we get the one way of getting the solution, 3 dx equal to dy. Integrating both the sides, we get 3x equal to y plus c1, or 3x minus y equal to c1. Because I'm having y minus 3x over here, so I would like to take minus common from this. So that becomes y minus 3x equal to minus c1, take that as c1 dash. So this is one way of getting the solution. The another way of getting the solution is if I consider first ratio and the last ratio. Let me consider these two. One, from first and last ratio, dx divided by 1 equal to dz divided by 5z plus tan of y minus 3x. Y minus 3x is equal to c1 dash. So I'm writing here c1 dash for this, using, let's say this to be as 1, using 1. Is it okay? Fine? Okay. So when integrating these two, we get x equal to, if I substitute this to be equal to y, so 5z plus tan of c1 dash if equal to y, then 5dz, if derivating both the sides, we get dy to be 5dz. So this integration becomes, for dz I'm writing dy by 5, and for the denominator I write this to be as y. Taking this 5 to the other side, we get 5x equal to, okay, the integration of 1 by y with respect to y is log y. So this is log y plus the constant, and this is 5x equals to log of what is y? It is 5z plus tan c1 dash plus the constant. Let me name this constant as c2. We can put back the value of c1 dash, 5x equal to log of 5z plus tan of y minus 3x plus c2. So from here we are getting the value of c2 to be 5x minus log of 5z plus tan of y minus 3x. And now writing the general solution. So this is f of c1, c2 to be equal to 0. Okay, c1 dash. So that is f of what is c1 dash? It is y minus 3x, comma, and c2 is this solution, fx minus log of 5z plus tan of y minus 3x equals to 0 is the required solution of the given differential equation. Alright, thank you. Have a nice day.